Good. Does anyone have any first topics you guys want to go over for the exam? Like anything you guys want to refresh on? Okay. Let me start off right now. So does anyone have any topics that you guys want to go over? If not, then we can just start off like with like one of the concepts. The way it's going to be formatted is how you're often going to just have the code. Wait, sorry. Okay. You're often just going to have the code, and then there's just going to be blank parts in the code that you're going to have to fill out. That's most of the format of the exam. You won't have to write the full code of a program for his exams. It's mostly just going to be fill in the blank and riddle questions and like the output of this code, basically. But does anyone have any topics you guys want to go over first? It's most likely going to be a queens. That's going to be like it's going to be the major ones, the major numbers on across is possibly as well. But it's going to be like the major programs that you guys went over, like the big ones like Towers of Hanoi and A Queens, that kind of deal. So does anyone have any first topic questions you guys want to go over? Okay. Towers of Hanoi. Okay. Okay, so for Towers of Hanoi, it's gonna be if, then from equals to else from. This is gonna be the typical format of how a question would be like. He's for the questions he's gonna ask in the exam. He's mostly gonna ask like the okay conditions in the program, like such as the marriage problem. He's gonna ask the okay function, which is like the statement of like whether this match is better than the other match. That's how the format is gonna be for the exam. So for Towers of Hanoi, it's gonna be like this, where you're gonna have to fill out the the statements for each. So this one's gonna be get um, get from tower, get from tower. So does anyone know the the code for like the statement for to get the from tower? So we have like the three towers. B, C. We have tower A, then we have tower B, then tower C. To get the from, we want to get the the smallest number out of the two towers that we haven't touched yet. So let's say our from was originally right here. Or from the next time we check, we won't be checking the same tower we were in before. We're gonna be checking. Wait, no, no, wait, no, that we won't be checking the two tower. We won't be checking the same two tower. We're gonna be checking the other two. And the way the towers of Hanoi works is that we want to move the smallest disk out of the two other towers. So either B or C is gonna have a smaller disk, and then that's gonna be our from. That's the disk we're gonna be taking away from the tower. So to do that, right, we're gonna have let's write this here. We're gonna have T 2 + 1 mod 3 dot back less than 2. Okay, and this is gonna be your statement. So what this is saying, right, is that we already used the two tower from A. We want to check which which of the other two towers, B or C, has the smaller disk. So like that, we do 2 + 1, which is not here, and then 2 + 2, which is here. So down. This one is 2 + 1. This one is 2 + 2. So this is how we're gonna check the two towers. And we mod it by 3 because let's say let's say our tower was at I'm sorry. Let's say our tower, right? Our two tower was originally at this spot. Then sure, we can move it one space forward to make it 2 plus 1, so we can check the spot of C. But if we do a two, a 2 plus 2, it's gonna be outside. There's gonna be some like a fourth tower that we have no we haven't declared. So we're gonna have to do a mod 3 because that's if we do say if we're at 4, right? And we do mod 3, that's gonna give us just one. Just one, three. So we're gonna just come back all the way back here. And this is gonna be our 2 plus 2. This is gonna be our spot because we're modding it by 3. Does anyone have any questions about the statement, the if statement for the first part? Well, all we're doing is just checking the other two towers that we haven't that's not in two. So in this case, these are tower that we used before, and now we want to check the other two, which is A and C. And between those two, we want to check which one has the smaller disk that we can move. Does anyone have any questions so far about that part or no? Okay, I guess not. So I'll continue. So if this is the case, right? That means if this statement is true, if the TO plus 1 tower is smaller than the TO plus 2 tower, and that means the taller with tower with the smaller disk is TO plus 1. So we would return no, we would give in to from 2 plus 1 mod 3. That's if the case that TO plus 1, which is C, is as a smaller disk. So in this case, it would be the most recent disk is 3, and this one has 5. Otherwise, if it was the other case, if TO plus 2 had the smaller disk, we would do TO2 plus 2 mod 3. And that would be the case for the to get the from statement. This is what he typically asks in the question for Towers of Hanoi. He'd usually just ask for the if statement or for like segments of the code from Towers of Hanoi. Does anyone have any questions so far? Any questions so far? Okay. I also want to keep in mind that this is the code for odd towers of Hanoi. If you want to make it an even, then every like one would be replaced by two, and every two would be replaced by one. So you're basically just swapping the two values, and it'll make it an even check instead. Okay. If no one has any questions, then I'll just continue to get the other one. Okay. Okay. So now the next part for the powers of no check is the get 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 next to tower. So this is the next statement. So it's gonna be the same format to ask the question. If blank 2 equals to blank, else 2 equals to blank. Then we have the candidate. Okay. Okay, so A, B, C. Okay, for the to get two for towers of Hanoi. So for the if statement, we do let's see E from less than T plus one mod three dot back. Okay, so this is the statement for the two tower from our original from. So like let's say our from was here. We want to check which one is the bigger has the biggest last disk. So either A or C. If our from was at B, then it's either A or C that it's bigger than B's last disk. So let's say like because the other one of them is gonna be bigger, the other one's gonna be smaller than B. So let's say this was two, then one of them is gonna be one, and the other one is gonna be like let's say five. We're gonna have to choose the one that's the biggest, and then have that as our two. So let's say here we're gonna have from plus one mod three. We're gonna have to say the one that has the one that's bigger than the original from is gonna be our disk that we're gonna transfer to. So in this case, from plus one mod three is gonna be our bigger disk. But if this wasn't the case, then the other disk that would be left is from plus two mod three. That's gonna be the other disk that we have. Is there any questions so far? And like I said, this is gonna be like how most of the exam is gonna look like. Just like fill in the blanks of like the more important parts of the code. Any questions so far? Okay. And for the last thing, for candidate, we're gonna want our candidate to be T T from back. And also again, the back method is just to check the last disk. in the tower back. And that's gonna be the whole code for the to get the two tower. And then again, like I said, this is for the odd version. If you want the even version, all you're gonna have to do is just change out the one into two and so on, and then the two into one. Azure, it's gonna be yeah. I think it is cumulative, but it's mostly gonna be the programs that like were the most important parts, like the most important ones, like stable marriage problem or Towers of Hanoi or the Eight Queens problem, like that kind of deal. Any like small programs, I don't think he'd include. And even if he does, they're usually like not crazy difficult. They're more simple, or like more of the obvious statements. Again, the exam is out of 150 points, so even if you don't understand the question, you could always just rely on the other problems to help you out as well. And he usually includes riddle questions, but they're more logical and fun rather than like too like tricky and stuff. So don't let it get to you if you don't understand them. There is one riddle question that I have that we could go over, but it's more of like just like knowing the answer. That's it. Does anyone have any other topics? Okay. The dynamic allocation. Let's see. Can you tell me like what kind of like question dynamic allocation is? Like if it's pointers or programming? Mhm. Okay, let me see. Do you know how the code would do you have the code for that? He's like, I need to just look at it. My bad. I don't think I have it. My notes. Okay, thank you. And if there's any more questions you guys have on other topics, You could like put them in the chat so I could keep them track on them. Yeah, yeah. For us, yeah, the same here for me. And Queens, but for pointers wasn't really covered, so we didn't really have it in our exam. We didn't have it at all for our exam. We just had the other main ones. Like the ones that you guys have gone over like a lot is typically the ones that are gonna be on the exam. Mostly the statements. If you want to go over it, we can, but I'm not really sure of like if it's gonna be included though. So yeah, is that okay with you, Ezra? Not bad. If you want to go over it, because it's typically just like knowing the okay statements. That's it. Okay, sorry. For red class, okay, sure. You can go over red class. Make a new template. Okay. So for red class, right? The red class is gonna be mostly about fractions. That's what the whole class is about. It's supposed to have the numerator and the denominator. And what he's typically going to ask you is the operation for like the plus for adding two fractions. So how that's going to be out, how that's going to be right is going to be ruler rat. So you're going to return a rat operation operator. Operator plus rat rat r and the curly brackets, and then you're going to want to return a rat. So you'd have a new rat being made. So this is what the headline function is going to look like. You're going to want to return the class rat, which is what you're going to give back, the name operator plus. So you're going to want to add the two. And you have rat r, which is the fraction you want to add to your own fraction. And then you want to return a rat. So you're going to make a new rat. So t is going to be our new fraction. So we're gonna have like t equals and the numerator and the denominator right here. And we have two rats already, right? We have the r rat, the r fraction, which is some number, and then we have our own rat because we are in our own method. So it's just gonna be ourselves. So we can just say like this or our own and our own number. Do you guys get how like this where this came from? This section? And where R came from? Okay, so yeah, okay, so I'll continue. So yeah, what he's gonna ask is operation mostly, most likely. He's not gonna ask for like the actual code. So for this, right, is gonna be like our template. We're gonna have the final fraction b and t. So t is gonna be the summation of r and this. So let's say, sorry, t is gonna be the summation of r plus this. So the way to do that is we're gonna have t dot n, which is gonna be our numerator. And for fractions, right? Let's say we have two fractions. Let's say you have 2, 3 plus 6, 6, 1. The way we can typically do this, right, is that we have to make the denominators equal to each other, the same. We can multiply this by 2, but like we won't know how to do that in the code. So instead, we can just multiply each other by their own by their opposite by the other's denominator. So this one can be 3 times 3, and this one can be 6 times 6. And in the end, it's going to be 12, 18 plus 18. 18, yeah, 18 plus 3. So now the denominators are going to be the same, and now we can just add the top altogether. So in the end, it's going to be 18 plus 15. So that's how we want our code to function as, our code to work as. So to get the numerator, we're gonna want to do n times, wait, that's right. N times r dot d plus d times r times n. And that's gonna be our top part. You see that here, this is our n and this is our d. Sorry. And then what was it? And 3, 2. So this is our n, this is our d, and this is our r dot n, and this is our r dot d. And so we're multiplying n times 6, which is r dot d. So this is going to be r dot d times n, which is what we got for the first part, n times r dot d, plus r times n times 3, which the 3 came from the denominator. So it would be r times n times d. That's going to be our numerator for our new fraction. Okay, so that's for the numerator part. Our denominator part is much more simpler. So t dot d equals to d times r dot d. So all you're doing is just multiplying the two denominators together, and you have your denominator. Then after that, all you're gonna want to do is return t. That's the problem he's most likely gonna ask you for this. question for the rat problem. Is that okay, guys? Does it make sense so far? Or is there any questions? Any confusion? Okay, okay. Yeah, I'll repeat the TN. Okay. So let me just erase this. This is a bit much. Yeah, okay. So recall how for a fraction, right? Let's say 1 divided by 2 times 1 over 3. Oh, plus, my bad, sorry. Plus, we're gonna want to add these two fractions, right? So the way to do that is that the trick is we need to have the denominator the same number. So the bottom number to be the same. So we can just add them together individually, like the tops. Because if they're two different denominators, it's going to be difficult to add them together. So we can just make them both equal the same denominator. So we can just add them together. So to do that, right, we can't like multiply two by two to get like three. There's no multiple to get three for two. So what we can do is just multiply them each other by their denominator. So this one for this one, right? We can multiply it by two, and then this one you can multiply by three. Is that good so far? Do you guys is this clear so far? So yeah, okay, good. So then, okay, let's multiply it. Three times one, top part would be three, and the bottom part, three times two, that'll be six. Plus the next number, which is this one, these two. One times two is two divided by three times two, which is six. So now that the both the denominators are the same, we can just add these two together at the top. The denominator would stay the same because it's just a fraction. And the top one would be added. So this one would be three plus two, which is five. Is that good so far? Okay. So then so we figured out how to get the numerator, right? We need to multiply this denominator, I mean this numerator, by the other fraction's denominator right here, which is right here. We did this two right here. And same thing with here. For this numerator, we have to multiply it by the other's denominator, which is right here. Sorry, which is right here, right there. So in the end, let's just call let's just call this for this, and let's call this fraction our r, like how we did before. Like our r that we got from here, and our this from our method. Okay. So this is gonna be our this, and this is gonna be our r. So what we're basically saying is how we're doing one times three, right? Because it's happening it's right here. The three came from here. The other one's the denominator. So what this is saying is that this is gonna be our n. Remember, because we called this fraction this. from our method. And this fraction right here is going to be our R. So basically it's saying N times R times D because R dot D is our denominator right here. And N is just our numerator that's right here. That's going to be what it is for the for the top part. Yeah, because so look, uh, okay, so we found so this will be three, right? So we have this part, we have this part, but then we still need this part. We still need to add the other side, which is where like you said, D times Rn comes from. So the next part, right, would be our denominator. So let's do it the other way. Let's do R dot N because that's basically our numerator right here, no? Right? That makes sense so far, right? Or no? Yeah. And then from there, remember, we want to multiply it by two, which came from the other our this denominator. So Rn times the original denominator, which is basically 1 times 2. Because our denominator is 2 for this, and for R, our numerator is just 1. So, so then, yeah, our Rn is 1, and then our denominator is 2. That makes 2. So now we have these two numbers right here, which which makes sense in a fraction. Which is 3 plus 2 is equals to 5. Does that make sense so far? Yeah, I don't know why they switched it over to like some other. I think it would have been much better if they did it in this order, Rn times D, instead of doing D times Rn, because it could throw people off. But you could do it in any order. He wouldn't take any partial credit off just because you moved the order. It's still the same thing in the end. Okay, and then yeah, for the what's it called? Say for the other version, like the minus version. I don't know if he went over it, but like there's also like minus. So for minus, it's the same thing. All you're doing is just making it minus instead of plus. Okay. And that's it for the rat operation. This is most likely what he's gonna ask on the exam. He's not gonna ask for like the actual code. And again, if you come across a question that throws you off or you have no idea how to answer it, then you always have the other questions to make up for those points. Because the exam is out of 150 points worth of questions, but you only need 100 max to get 100. Okay. Is there any other topics you guys want to go over? Upstream, upstream, output. Yeah. Maya. Mhm. Can you explain the operation overload? My bad. I just need to like know what it was. Can you explain a bit more on the operator overload part? How to print and assign variables using input output. Mm, I'm not sure how that one entirely works. MD, do you know the, the output and input stream?
I'm not sure. I was just looking for it. Mm,
Yeah, I'm sorry.
that's okay.
Yeah. Yeah, I was looking through my notes as
Yeah,
well.
like I have something called like memoization.
For the
I'm not sure if that's like input overload, because like when I hear like overload, I remember the thing. We did the Fibonacci numbers
yeah.
with recursive
Oh,
function, but at
yeah.
some point, if it stores every number, it takes too much memory. So we stored in the memory, like the actual like the same numbers, so that
Yeah.
like we don't use the memories. But I'm not sure if that's the question.
Okay, it's fine. Yeah, my bad. I don't think I think he'd go over it, honestly. Probably not. And I don't recall it having on my final exam as well. Yeah, sorry. But is there any other topics you want to go over? Maybe we can go over stable marriage, maybe. Okay. We can go over stable marriage. We can go for over dereferencing and the dereferencing and stuff for pointers. And let me see. We can go over structures as well if you guys like to. Over structures, stable marriage. Okay. Yeah. Okay. If there's no other topics, then I can try to make one up on the spot right now. This is this one. I have. So as you know, in C++, right? In C++, if there's like an array called A of three slots, 0, 1, 2, we can just say A at 1 would give you the value at that index at 1. As for C, however, for C, the language C, we usually say, so quick, we usually say for the same one, for the same index, we do A plus 1 dereference, and that would give us the value 1. Remember, an array is like a pointer to the very first line of the index of the array, and then adding on would be the next address, like right next one, and then that would give you the address. But if you want to dereference it, you have to put the star next to it. That would be dereferencing. The star has multiple meanings. It could be either out of these three. I'm not sure. I'm pretty sure it's only three. It could be multiplying, pointers, and de dereferencing. Dereferencing. So I can go over an example for this. Okay. Go. Okay, so let's say we have zoom in. We have int s, int star, r, int n. And then we have, so this is going to be a recursive function. So if n is equal to 1, then you return r dereference. So like this, else turn r plus n minus 1 star s r n minus 1. And that'll be the whole function. And then we have our main. So let's say we have int a equals 5, which is the array of 10, 20, and 30. And we want to do a C out S, and we pass in A, and then we pass in 3 and line. And we want to know the output of this code. Okay. for this part, right? And the method no the function s is taking in address of r and an integer n, which is 3 and a, which is our array. So our array would be a at a 10, 20, 30. Yeah. 10, 20, and 30. That's going to be our array. So we're going to want to know the input, the output of this code. So what kind of reference is this for this star? Because remember, there's three meanings to like a star. Is multiplying, pointers, or dereferencing. So what kind of star is this first one for the parameter of s? What's it taking in? Yeah, pointer. Nice. This first part is gonna be a pointer because a, you see it's being put into the into s, into the parameter of s a, and we know that an array is a pointer starting at the very beginning index of a. So right here will be a plus one, and then right here will be a plus two. So yeah, the first one is a pointer, and then sure we have the array r. I mean the array r. Then we have an integer n, which is 3. If n equals to 1, which it doesn't, then we return r star. In this case, what would this mean? What would this mean? Like, what would it return? Would it return like which of these three would it return? Yeah, it returned the first element of A because it's dereferencing the first the first address. So like to say right here is R. If we put a star in front of it, it would mean you're dereferencing it. Instead of an address, it would be the actual value at the address R. So it'd be 10, yeah. So in this case, this would be 10 in the end. And then else return R plus N minus 1. And then S R N minus 1. So this again, what is this part doing? It's dereferencing, no? And then this part is multiplying. It's multiplying the address at Rn minus 1. So in this case, right, we have R, and then we have Rn, which in the first variation is going to be 3. So R plus 3. Remember, it's also a minus 1, so we're going to have it there. And we're going to be wanting to dereference it. So in the end, it's going to be 3 minus 1 is going to be R plus 2, dereferencing. So what element would this give us? This would give us, this is R plus 1, and this is R. This is R plus 1, this is R plus 2. So in the end, it's going to give us the value 30. And then the rest after that, remember, we're multiplying right here. So we don't know yet. So yeah, we'll be multiplying right here. And then this is our recursive case. We're going to be calling it recursively. So it's going to be 30 times times S of R, the same beginning address of A, and then minus and then N minus one. So before it was three, now it's two. Okay. So then R plus two. So now we go over the this case again. So now instead of three, let me erase this, sorry. Okay. And so instead of three, this now be two. So now we run this code again. So now this section instead would be return, it would return R plus N minus one. So same thing here. Star R plus N, which is two minus one. So in the end, it would just be R plus one, which is the first element, the first index one of our array, which is 20. 20 times, so it'll be 20 times S of R minus N minus R N minus one. Our N is two, so now two minus one is just be one. And now we run this case again. Our N is actually one this time, so this case would return. It would return R dereference. So this would return R dereference, which is what? The the first the beginning of the array, which is 10. This would be 10. So in the end, all you're doing is 30 times 20 times 10. So all you're doing is just basically multiplying every element of the array for the function. Which is gonna be 6,000. Do you guys get it so far or no? Is there any questions about it? He's most likely gonna ask this kind of question where like what kind of star is it? Is it either multiplying pointer or dereferencing for some small function? He's probably gonna ask that. Or like the output of the function. This one, all it does is just multiply each multiply each element of the array together. Why are we multiplying all? You mean the recursive case, like in the end, like right here? Like right here? Okay. So that's what the recursive case is doing, right? So the first part, right? When we had three, we had n did not equal three did not equal to n, or and the three would not equal to one. So we would skip this case and we would return the dereference of three minus one plus r. It would just be r plus two, which is 30, which is the first index. So that would be this part. That would be this part. And then it says times this part, but you don't know what this part is yet because it's calling itself. It's calling the function again. So you'd have to run the code again. Sorry. Yeah, you have to run the code again. And there will be S plus SR2. Do you understand why I got the two from? Or where I got the two from? Okay, yeah. So then so for this part, which is the function all over again, we're just calling it again, but instead of our n being three, like how we did originally, like right here, instead it's gonna be two because we subtracted one right here. So instead it would be 2 instead. And then we run the code again. 2 is not equal to 1 again right here. So we skip. And now we do the dereferencing again, but instead it's going to be r plus 2 minus 1 is going to be r plus 1. And that's going to be our, our index right here at 20. It's going to return that. Okay. Yeah, 20. And so that's going to be our value for S, R, and 2, right? But remember, it's returning both that and this part as well. This part. So we go back. Okay. We returned we got 20, which was from this part itself, but we still need to multiply it by this part. So we do it again. S R, it's gonna be this again. So S plus plus R plus 2 minus 1 is gonna be 1. Wait. Yeah. Anyway, let me see. It's gonna be 2 minus 1, and it's gonna be 1. So that's what we're plugging in here. Is that good so far or no? Yeah, we're multiplying it again because we're calling it again. It's like it's like Fibonacci or factorial. It's like that. We're calling the function again in this part right here. We're calling it again and also multiplying it by the index of the array. So it's like, yeah, it is like Fibonacci. Yeah, we call it until we get 1, which is right here. Right here. SR1. And we know that when we plug in 1 for n does equal 1. So we return the first element of the array, which is R star, which is R, because our address is right here, RR. And since we're dereferencing it, it's no longer an address. It's going to be the actual value now, which is right here, which is 10. So it's going to be, so then it returns 1. So we know that this part, this whole part is going to return 10. Yeah, so it's going to return 10. So then, okay, let me hold up, let me erase it real quick. Sorry. Okay. Okay, so now we're going to be like, okay, so now that we know what the value was for when we gave in R and 1, it's going to be 10. So 10 times this is going to be 10, 10 times 20, 200 in the end, which is going to be what this value is because we're returning it here. So it's going to be 30 times 200, which is 6,000. Is that good so far? Okay. Do you have any questions about it? Okay. So that was one of the questions I want to go over. If you guys want, we can go over structs. I have an example of that as well. But it's more going to be about checking the size of struct. Okay. Okay. So we have, let me make it better. So we have struct, struct, student, And also, struct is very similar to an object in C++. Plus plus. Very similar. String. Wait, sorry. It's really good. Name ADDR, ID, and double GPA and integer, integer semester. Okay. So this is going to be our structure, and we're going to have an array of students. So it's going to be students of, let's say, the class CS211. I'm not sure how big your class is, so I'll just make an estimate of 5 and 10. It's probably bigger than that. 10. Yeah, okay. And then the question is, make it yes, 11. Okay. Oh, wait. Okay. That's the question. So the way we answer this, right, is recall how, remember, if you have like an integer array, like an integer array of, let's say, 5 and 2. No, let's not do that. Let's do 3 and 2. This is gonna be, sorry, 3 rows and 2 columns. So 3 rows, 2 columns. Gonna be like that. And to find the size of the array, right, we know that each one is holding an integer. And how big is an integer in terms of bytes? Yeah, 4 bytes. Okay. So we know that each slot of the array is 4 bytes. So 4, 4, 4, 4, 4. In total, that's six, 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 um, 6 slots of 4 bytes. So it's literally just 6 times 4, 4, sorry, 24. So that's the case for this, this is basically it. 3 times 2 is 6, and you're being all the way over here. and multiply it by the by what the array type is. Okay. Simple enough, right? So we can say the same thing for this. For students, we want to make an array size of five, 5 rows and 10 columns. To get the actual number of slots, all we have to do is just do 5 times 10, which is 50. Now we have the number of slots, and now we need the data type to multiply it by. But what is the data type? It's students, no? And you don't know exactly the size of students. So what we can do is we look at this. We know the structure of students has a name, an address, an ID, a GPA, and a semester. So each one is its own data type, right? A string is a name. A name is a string. An address is also a string. An ID is also a string, and the GPA is also a double, and integer and semester is an integer. So What's the size of a string? Does anyone know the size of a string? Yeah, it's eight. So strings are a size of eight. So that means every string is a size of eight. Right here, right here, right here. Does anyone know the size of a double? Does anyone know the size of a double? Yeah, double is eight. So eight, and we just discussed this. Integers four. So integers four. So basically, the size of a student, the the structure size of a student is just all of these combined into one value. 8 times 4 is 32, and then plus 4 is 36. So it'd be 36. So let's write this down. Each student is of 36 byte, byte, byte or bit? I think byte, byte. I think so. 36. Correct me if I'm wrong. 36. So now we have the size of the student, of each student, and we have the size of the array, which is 50. So all we gotta do is just multiply these two, 36 times 50, and that would give you, sorry, is 1,800 bytes. Bytes. And that's the typical question he'd ask. Waxman would ask for this kind of topic. You guys get it so far? Does it make sense so far? Does it make sense so far? Okay. Then I guess Does anyone have any more questions? If anything, I can move on to marriage problem if you guys would like me to. Okay. Guess I'll go to marriage problem right now. So let me see. So for marriage problem, let me see. Let me see write down. Stable, stable marriage, stable marriage problem. So we say if the current the current man prefers prefers the new woman to his partner. Sorry, to his partner. Here it is. To his partner. To his partner. Partner. To his partner. And if the if the new woman, the new woman prefers the current man. Current man to her partner, then that means unstable. So this is the first case for the stable marriage problem. Alright. So the way we'd answer this, right, is that okay, just like in the code, or to say a current someone, we'd use C. And for the new person, we'd use I. So in this case, C is current and I is new. It's a good way to memorize it. So when we say we want if the current man prefers the new woman, we say current man is C prefers the new woman, let's see, which is U of I, his partner. And when we say if the new woman, we say Q of I prefers the current man. So let's just see. Okay, to their partner. So to write this statement, right, we need to use an if statement. So let's make an if, and we'd say if the male preference or the current man and the current woman greater than the male preference of the current man and the new woman. Okay, that's the first part. So it says if the current man prefers the new woman to his partner, and if the new woman prefers never mind. It's if the current man prefers the new woman to his partner, which is what this says. And you may be confused on why this is greater than, because you're saying basically saying here that the number for current man and the current woman is higher. It's a better match than the current man and the current and the new woman. But remember, for this program, the lower the number, the lower the rating is better instead of the higher the number. So in this case, this is the outcome of what it's asking, like right here. That's what it's asking. It's saying the current man, which is right here, prefers the new woman, Q of I, to his partner, which means her current woman, which is Q of C, which is which is right here. So the lower the number, the better. So that means if this match is better than this match, then that's one case approved, right? And now we want to check the and statement. So now we do and and let's see. And if the woman preference Q of I and so if the new woman and the new man have a bigger number than woman preference of Q of I and the current man, and that also is the other case. So right here we're saying if the new woman, which is Q of I, prefers the current man, which is right here, to her partner, which is let's see, Q of I. You sure? No, I, just I. So it'd be like this. So the lower the rating, the better. And since this pair is better and this pair is better, you see that C and Q of I are opposites. This is better compared to the I and CC. This means that both of them make a better pair than the current person they're with. So then after that, you return false, meaning that it's unstable. Yeah, that's unstable. And that's only one of the cases. There's the second one as well. But so far, does this make sense to you guys? Does this make sense so far, guys? Or no? Do you have any questions about this? Okay, I'll continue then. The next case. I'll write it this time because I think it's faster. So for this case, we say, so then we case two, if the new man prefers to be with the current woman to partner, and if the current woman prefers the new man to her partner, we have an instability. So this is the second case. So it's right there. The second case, if the woman prefers to be with the current woman to his partner, and if the current woman prefers a new man to her partner, we have an instability. So, like I said, C is current and I is new. So in this case, we have an if statement. So if the new man, so new man prefers, so this is going to be male preference. So male preference, male preference. The new man, which is I, prefers to be with the current woman. So this would be Q of C. You see, first to be. Oh wait, no, this is wrong. My bad. Sorry. Sorry. Let me fix it up. Let me just do this one first then. If the male prefers to be with the current woman, which is Q of C, instead instead of her instead of his partner, which is Q of I. So this makes sense so far because the new the new man is is in a relationship with his current with his new woman, which is Q of I. And if this was the lower number, which is like the better case of the new man preferring the current woman, then it makes a better match. So that's that first part. And now we have to do the and statement. So now we do and and if the current woman, so this just mean woman preference, so WP. If the current woman, so that would be Q of C. Q of C, then I'd have the instant woman preference Q of C. If she prefers to be with the new man, which is I, compared to being with her partner, which is C, then that test case fails as well. So it would return false. Return false. Otherwise, if both these cases fail, then it would return true, and that marriage is stable. Does it make sense so far? This is what the type of question you'd ask. You'd probably ask for either like one of these or one of these in the end, or this kind of question. Maybe even the full maybe. I'm not sure. Maybe possibly. But does this make sense so far to you guys? Does anyone have any more questions we can go over? Because if not, then I think you guys are ready, and it won't be too bad. It's out of 150 questions, 150 points worth of questions, and we can close it off early. The review. Some key topics for sure is going to be on there is Towers of Hanoi, marriage problem, probably, most likely, and some like knowing of like the bits, like I mean, yeah, bytes, like the size of an integer and stuff like that, and also do a bit of recursion. We haven't gone over that much, but recursion is most likely going to be there. He's probably going to ask you for like a question about like what's the output of this going to be, and it won't. All you should really do is just like try to like do it by hand. That's about it. Towers of Hanoi, stable marriage, and a queen's problem. A queen's problem can vary, but it's usually the same thing for most of the versions. It just like depends on like if she wants like a different kind of version. But those mainly are going to be on the exam for sure. A queens, stable marriage, Towers of Hanoi, and a bit of recursion and bites and stuff like that. There should be past there might be past exams online. I'm not entirely sure if I mean did he guys give you did he give you guys a review sheet or like a some practice problems to go over? Because if anything, going over the previous exams is a really good way to go over some stuff, or even your projects. Just like looking over the code, mostly the okay the okay functions, and like to make sure it makes sense. Oh, that sucks. I'm sorry, but yeah, if anything, the projects you guys have done is a really good way to look over some of the topics you guys went over. Just like look at the if statements and such, or like the while loops, something like that. Because most of the exam is gonna be like fill in the blanks. There really is no like write the whole code yourself kind of deal. It's just gonna be the it could be segments of the code. That's it. No writing the whole code exam. And there's gonna be some riddles, I think, but those are more just for fun to help you out rather than like to target you. But yeah, like what MD said, it's a really it's like those kind of topics. But don't worry too much. He gives a really good curve, and his exam is out of 150 points. So you have more than enough questions to like skip over do one to do the ones that you actually do know. So it's a good way. It's a good method. If you guys have any questions, then we can stop the review session and stop recording.